So here it is. So far, what you have seen, and this is, of course, this is ridiculous, and I want to make a quick correction here. This is 62 and not 52, right? And this problem, like I said, is about your the basketball making 80 points using 2-pointers and 3-pointers, 37 shots total. What do you notice as a pattern here? Okay, what do you see here as being constant throughout, never change? What stays the same for each line that you see? You multiply by what? By 3 and by 2s. Notice that everything is multiplied by 2s and 3s, right? So the only thing that what you see as a constant here is the 3s, 3-pointers, and the 2-pointers. What's changing is the number of shots on each, right? But even if these two numbers change, what do you notice about the sum of each two numbers? Huh? They always add to 37. So in other words, the shots is being bounded by or restricted by a number of, in this case, the problem says that since the Lakers only made 37 shots, you're being bounded by it. Is that true? Okay. So I want you to look at this problem in a different light. Okay. What does that mean? Well, think about this. This whole project has been about mixture. Mixture means you are taking two things and then you mix them together to come up with something different, right? In this case, we have 2-pointers and we have 3-pointers. We mix them up. We have a total scores of 80 points, right? But what we notice is that I don't care how many shots you made in a 2-pointer category and a 3-pointer category. The end result is you made a total of 37 shots. Do we agree on that? Okay. So what you should start thinking about is, all right, so what are the two things we need to identify? The 2-pointers and the 3-pointers. So let's say for the 2-pointers, can we declare that, hey, let's X here equals to the number of 2-point shots. Can we just go ahead and declare that? And let Y here represent the number of 3-point shots. Okay? So now we have two unknowns. We don't know how many 2-point shots. We don't know how many 3-point shots. But we know that if I add these two together, how many shots total did they make? 37. So, in other words, don't we just have one equation down already? Look at that. We know that if we take the number of 2-pointer shots and the number of 3-pointer shots, add them together, we have a total of 37 shots. We agree? And then now you look at the table that you did here. How do we calculate the points? Let's say I make 5 2-pointer shots. How many points was that? 10. How did you do that? 5 times 2. Let's say I make 11 2-pointer shots. How many points was that? So what did you do again? Multiply, right? So the key here is you take the points worth, the point value of the shot, times it by the number of shots you made. Is that true? So in other words, if you want to find out how many points you made for the 2-pointers, don't you take 2 points times the number of shots you make for that category? 2 times X will give you the total number of points for the 2-pointer shots. Is that agreeable? Okay, and then would you also repeat that for the 3-pointer shots? So I don't know how many shots I made for the 3-pointers, that's why I'm declaring that as a variable, but I know that each shot is worth how many points? 3. And so can we say that 3 times Y here will be the number of points for the 3-pointer shots? If I take the combined points value of the 2-pointers and 3-pointers, what is the total number of points in this problem? 80. There it is. And look what we have. We have ourselves 2 equations. I hope you also see this pattern that, notice that since we have 2 unknowns, to solve the 2 unknowns, we need to have 2 equations. And the trend will continue that way. Imagine if we have 3 unknowns, how many equations do we need to have to solve for 3 unknowns? 3. So that the pattern will repeat itself. So before, when we first learned to solve for one single variable, we only see how many equations? 1. So 1 single variable, 1 equation. 2 unknown variables, 2 equations, and so on. But then you look at these 2 equations right here and you're like, okay, so how am I going to solve for this? Let me show you this very good technique. And we call this technique the elimination technique. And it will make your life a lot easier. But for the elimination technique to work, you have to first check to make sure that everything is aligned perfectly. Meaning I have the x column aligned, I have the y column aligned, I even have the equal aligned, I even have my number column aligned. If they are not aligned, you are not in a good case yet. So you have to make sure that everything is aligned. Next thing you do is you just pick a column to focus on. To basically, remember I told you this method is called elimination method? So pick a column you want to get rid of. Which variable column would you like to get rid of right now? Pick one. The y. So let's say I want to get rid of this y column. Okay, getting rid of is either subtracting or adding, right? Because sometimes, if I have something like this, what do you put in between to get rid of it? Add. See it? So it depends on the actual value. So you would add to get rid of. In this case, what would you put in between to get rid of? Subtraction. So you've got to adapt to the sign, really. If you have, notice the same number, you would subtract to get rid of. But if you have opposite numbers, you would add to get rid of. You see how it works? But for it to be, if you want to get rid of it, you need to have the coefficient or number in front of the variable the same. Are these the same yet? Can y take away 3y to get rid of everything? No. So how do you make it the same? Which one would you make it the same, though? How would you turn it to the same number? In this case, you have a 3 here, and this is a 1, right? So how do you make it the same? What do you think? Oh, multiply by 3. Okay, by 3. So in other words, if this turns to 3, then you can actually get rid of. Is that true? So you have to make the two coefficients the same. Now we're going to have another case soon, but for now, yes, and that's how we get rid of it, by multiplying by 3. But as you know about the rule of our equation is, when we multiply something by 3, just you have to multiply everything by 3. And because you are modifying this first row, everything in this first row will be multiplied by 3. You see how it works? And so let's distribute. If you multiply everything by 3, what will you have in the first row? 3x
plus 3y
plus 3y
equal 81.
equals to 81, you said?
Yeah.
I don't think so.
Or it's 170.
117.
No,
Come on.
111.
111. Okay, and then I'm going to go ahead and shift this over because I don't need to modify anything, right? So it's going to be 2x plus 3y equals to 80. And once again, I want to bring your attention to the column that I want to eliminate. In this case, how do I eliminate? Subtraction, because they are the same. To get rid of, I subtract. But don't forget, if we do one to one column, we have to do it to every single column as well. So subtract, subtract. Watch what happened. What does 3x take away 2x?
1x.
1x. And this is gone, right? What is 111 minus 80?
31.
Ah. And what did we define our x to be? The 2-pointer shots. So that means I made 31 shots, 2-pointers. If I make 31 shots of 2-pointers, how many 3-pointer shots did I make? 6. And how do we solve that? Well, technically, you can actually use this one again. Plug the 31 back into x, right? So that means you got 31 plus y equals to 37. And as you can see, if you solve for it, you end up with y equals to 6 shots. So y represent the 3-pointers, and there you have. Yes?
When I was in Friday school, the teacher or whatever made me go ahead in chapter 5. So I went up like 2 lessons, 3 lessons up.
That's fine, but there it is. The elimination method get you the exact answers. You see how it works? Okay. I want to show you something very interesting as well. This, of course, will work on your previous problem about the car problem, right? I want to show you something. So recall this particular equation that we just did, and we will be doing this when you come back from your break. And the program that we're going to be using right now is called GeoGebra. Okay, so let me go and show this to you. It's actually very interesting. You can actually download this. This is free, completely free, and you will love this program. So, yes, GeoGebra. Geo, you know, like the first geo word, and then gebra. So it's a combination of both. All right, so we came up with 2 equations, right? The first equation is the number of 2-pointers plus the number of 3-pointers will give us the total of 37 shots. So I defined the x to be, notice here, let me just go and zoom in and show you. I defined the x to be the 2-pointers and the y to be the 3-pointers. The number of 2-pointers and 3-pointers add up to 37. We agree? So I just enter the equation. I hit enter. Okay, you don't see anything yet, but that's fine. And then the second equation is what? 3 times, is it 2x? 2x plus 3y,
Equal 8.
because you know why it's 2x plus 3y?
Yes.
Yes, why? Why?
They make the
Yes,
2 is the amount of 2 pointers
Uh-huh.
times x flipped, like
the number of shots, right?
number of shots.
Okay. All right, and the total number of points will be
80.
80. Okay, now let me go and zoom out and show you something. I want to show something here, right here. You see this two graphs that we got? It came from our equation. But notice that when you graph this particular one right here, there is an intersection. I wonder if you can actually see where they actually intersect. Let me show you how it's done. Let's see if you can actually see this. There has to be an intersection. There it is. Okay, intersections. So I'm going to go and find it. Right there. And look at this answer. See, point A is where the intersection is. Look at the answer. 31x. X, we define x to be what? The 2-pointer. And 6 is the y. Y we define it to be? The 3 pointers. And where the intersection occurs for the two graphs, that is our solution. So graphically, we can also find a solution that way. Okay? So we will definitely be exploring this. I already showed you